Today on the Perception in Action podcast, a look at some recent research on representative design. How can we evaluate the representativeness of typical practice activities used in sport? What expertise differences emerge when we evaluate athletes in more representative test environments? So it's time for a call to action. Hi everyone, this is Rob Gray from Arizona State University and PerceptionAction.com. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. On today's episode, I want to look at a couple recent studies that focus on a really important concept that I've discussed a few times on the podcast now, representative design. As I discussed in detail in episode 88, representative design is a concept first proposed by Brunswick in 1955 and refers to the degree to which the elements of competition are represented in training. It is proposed that making a task more representative will allow athletes to use information to develop adaptive movement solutions that are more likely to transfer to competition. And in terms of research, we will better be able to identify aspects of perceptual motor control that are associated with superior performance. To maximize representativeness, coaches need to design tasks and researchers need to design experiments that 1. Ensure the functional coupling between perception and action, 2. Preserve the specifying information used in competition, for example, incoming ball flight information, and 3. Ensure that there's a high degree of action fidelity. That is, the movements performed in the task are similar to those used in competition. Many traditional practice activities are low in one or more of these aspects. For example, hitting balls projected from a machine is very common in tennis, cricket, and baseball. Although this allows for massed repetition of the same skill with high consistency, it alters the perceptual information available to the athlete and has shown to result in some distinct differences in the way the ball is played or hit. Therefore, it's important that we continue to challenge the traditional tasks that we use to train and evaluate athletes, pushing to a higher degree of representativeness where possible. So let's look at a couple recent studies that have addressed the issue of representative design. In a paper recently published in the Psychology of Sport and Exercise, Lyndon Krause and colleagues sought to evaluate the degree of representativeness of some commonly used practice activities in tennis. The study aimed to assess the representativeness of 4 commonly used training tasks designed to improve ground strokes. Representativeness was assessed in 2 ways. Qualitatively, using the Representative Practice Assessment Tool, or RPAT, the authors developed in a previous study. This tool involves a series of questions like, is the task goal specific enough for the intended outcome to be measured? Do the task constraints assist in transferring skills to competition? Does the task encourage variation between shots, within shots? Does the task encourage decision-making? For each of these, the rater, typically a coach, is asked to rate on a scale of 1 to 5. In the study, representativeness was also assessed quantitatively using the Hawkeye system, which is a series of cameras that allow tracking of ball flight and player movement. These variables were compared between the practice tasks and actual competition. The study involved 20 elite junior tennis players, 10 male and 10 female, who completed 4 4-minute practice tasks. Practice tasks included cross-court plus and cross-cross line, in which there are rules about which type of stroke the player is allowed to play and how the rally is started. They also completed a point play condition, in which the goal of the player was simply to win the point and there were no restrictions on the type of shots that could be played. And, as mentioned, results from these practice tasks were compared to actual competition performance data. What was found? Not surprisingly, the RPAT findings revealed that all of the practice tasks could be improved in terms of representativeness, with the point play tasks scoring higher than the other 3 restricted play tasks. These questionnaire results were supported by the Hawkeye data. Looking at tracking data, it was found that players hit the ball significantly faster, but from deeper in the court in all practice tasks compared to match play. Additionally, compared to match play, players hit more forehands, contacted the ball from locations significantly further from the center of the court, and hit with more spin in practice tasks. Overall, the observed practice tasks typically promoted more cooperative rather than combative behaviors expected during match play. Specifically, despite players hitting the ball faster and with more spin, they also had longer rallies, contacted the ball further behind the baseline, and hit fewer winners during most practice tasks. Overall, I think this is a really interesting study that shows how representativeness can be evaluated for real practice activities. The RPAT is a simple tool that seems to effectively identify areas in which the representativeness of practice tasks can be improved. And they seem to be highly consistent with what is found using the more complex and time-consuming method of analyzing Hawkeye motion tracking data. Thus, the RPAT might be something coaches want to consider adopting in assessing their own training methods. The second study I want to look at today is one published last year in the journal Frontiers in Psychology by Connor, Farrow, and Renshaw. The authors begin by noting that although we have found many differences between athletes of different skill levels in research studies, including abilities such as coordination, anticipation, pattern recognition, and decision-making, most of these tasks used in these studies are quite low in terms of representativeness. For example, a large amount of research on anticipation has used passive responses to videos. If we believe Goodale and Milner's two streams hypothesis, then this is likely to have only engaged the ventral pathway in the brain, that is vision for perception, and not the dorsal pathway, that is vision for action. Other areas where representativeness is lacking in these studies is the use of narrowly defined task goals and the lack of information about an opponent. The particular sport investigated in this study by Connor and colleagues was cricket. Previous experimental work on cricket batting actions have commonly utilized ball machines, explicit task instructions, or a combination of both to investigate technical aspects of the movement. The authors argue that explicit and narrow task goals given to the performer are likely to limit their ability to demonstrate their movement adaptability, therefore limiting our understanding of expertise. Another area that has been lacking is understanding how individuals at various skill levels perceive their own success at meeting task goals. The purpose of their study was to explore the interacting actions, cognitions, and emotions produced by cricket batsmen of different skill levels during a representative training scenario. The study involved 22 cricket batsmen, 6 state level, 8 amateur, and 8 junior state. The batsmen were tasked with scoring as many runs as possible during a simulated limited overs game. Actions, motion tracking, cognitions, interviews during play breaks, and emotions, measured using the Sports Learning and Emotions Questionnaire, were assessed. What was found? State-level batsmen played more scoring shots and scored more runs, underpinned by superior bat-ball contact and technical efficiency. Furthermore, the state players' cognitive evaluations of their own performance differed from lesser skilled players, in that they reported strategies based on external outcome focus, such as where to score runs, rather than focus on internal processes, such as making technical changes. State-level batsmen also reported lower levels of nervousness compared with junior-level batsmen. In terms of technique, state batters played significantly more shots off the front foot compared to amateur and junior batters, and state-level batters performed significantly less movements overall than both junior and amateur batters. It was also found that the higher skilled batters executed more varied vertical and horizontal bat shots while on the front foot and used later initiation of their initial foot movement and downswing of the bat. So some clear differences in terms of the movement solutions being used. In sum, I think these studies reveal important if not highly surprising findings. Many of the tasks that are currently used in practice lead to perceptual motor behaviors that are not representative of what occurs in competition. We also see clear differences in cognitive and emotional aspects of performance. Therefore, it will be important for future practice designers and researchers to continue to push the envelope in terms of developing more representative tasks. Also, as I stated before, I think it's time we put more effort into actually assessing the level of representativeness of tasks and paradigms we're using with tools like the RPAT. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials including an extra monthly episode and written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled. Cut you quick.